Hello and welcome back to the video lecture series on Python programming. This is Amit Kumar Das, and we are going to today cover the Python classes and the concept of OOP, how it is implemented in Python. What we are going to cover is a very basic part to get it started, how to create the classes and how to create the methods of classes in Python. And for more advanced programming, we can probably follow through with more complex hands-on, right? So let's get started. So when we say object-oriented programming, that means when we have the concept of object in the programming paradigm, uh, that in that sense, actually we have already used the concept of objects while doing the Python programming till now, right? So we have talked about objects of type list or objects of type dictionary, right? So already so far, whatever programming we have done in Python, it has included the concept of objects, but in a more generic way. Now, what do I need to do additionally to kind of get the real essence of object-oriented programming? For that, what we have to bring into the game is the concept of inheritance, right? So when we talk about inheritance, we talk about a hierarchy of inheritance, right? Say, for example, we have a parent class, okay, which may be the class of students, right? So all the students may belong to the parent class. From that, we may have child classes, say all the UG students and all the PG students, right? So this can be a UG, this can be a PG, right? Then again, under the UG students, we can have different branches, right? Or different child classes. It can be based on the departments, like you can have one branch for the CSE, the other branch for the ECE, and so on and so forth, right? So whenever we have an inheritance hierarchy, we say that the object-oriented programming concept has been actually implemented, right? So that's what we need to bring into the whole thing, right? So we will look at that today. So Python class is basically a device to create or implement new types or new objects, new kinds of objects in Python, right? So we have certain standard types. We can create certain new types using the concept of classes in Python, right? And how do we create a class? Very simple, just like how we create a function. Same way, we can create a class using the class keyword, right? So we have a class keyword using which we can create a class. We'll see that very shortly. And when we do that and when we create a class, after that we can actually create an instance of that class or instantiate the class, right? So that instance is also called object, right? And this is a very classical concept. I mean, we have already gone through the concepts of object oriented programming. If we have gone through, we already know it. If we have not, then just understand from this perspective that classes are like templates and objects are like specific what should I say, instances or specific examples created using that template, right? So when we print a particular object, what we can see is basically which particular object or which particular class it belongs to and what is the memory location where it is being stored. These are the two things you can, if you just create an object of any particular class and you print that, you will see something of this sort will come in, right? Now, why classes? Why do we need to go for classes? What's the advantage? So first thing is, again, the same concept of reusability. Whatever things, whatever attributes, whatever functions can be implemented for one particular class and can be reused in different classes. What we do? We simply have those methods or functions or attributes as a part of the parent class, and we derive different child classes from that, and the child classes inherit, what we call is inherit the attributes and functions from the parent class. So that's one way of reuse of the features and functionalities, right? Second, the child class contains the other objects that it activates, right? Each component might be coded as a class, which it defines the behavior and relationship. So one child class you can create inheriting from multiple parent classes, and the child class kind of behaves as a container of the different parent classes coming together and composing a new class, right? Which has a distinct behavior and a relationship, right? So that kind of a composition using different parent classes can be done using the concept of classes. Next, very important, one class can be instantiated into multiple objects or multiple instances. So essentially, classes can be considered as object factories, right? Or factories, where you can actually, you'll have the same code space, but you can have different data spaces, each for one object, right? So that is a big advantage. One particular code can actually be used to spawn multiple instances, and that those multiple instances will have dedicated data spaces. That is a big advantage. Next, customization via inheritance. So basically, you have got the features of the, I mean, when you call feature, it basically means the methods and attributes of the parent class, and that you can actually customize when you get into the child class. The same method can be customized in its own way. So that is a big advantage. You can actually inherit and customize methods, right? So that's a big advantage. And last but not the least, very important factor is operator overloading. This is a very, what should I say, useful concept and very easy to do in Python, implement in Python, where you can actually, the default mathematical operators can be actually overloaded, and it can be used for the user-defined types or user-defined classes. So the same mathematical operators which are generally defined for the standard Python classes or standard Python types can also be implemented for the specific user-defined Python classes or types, right? So this is another big advantage of using classes. Now, how do we create a class? Very simple way in Python. You can use the class keyword to do the same thing, right? How do I do that? Say simple class. I use this keyword class and then name the class which I want to create. Here I name it as my class. Then within the parentheses, what do I need to put in? If I want to do inheritance, I have to put in the parent class or the parent classes. If I want to inherit from multiple classes, I have to give the names of the multiple parent classes. In case I do not have any inheritance, I do not want to inherit from any class, I can simply knock off this part within the parentheses. So I can just write class my class colon and then write the different statements which are going to be part of the class definition, right? So it's very simple. I mean, just like how we define a functional block, function block, or if I define a loop, the same way we can define the class, only use the class keyword. That's it. Okay. Uh, Only one small thing. I mean, as a what should I say? As a convention, you can use the class names of the user-defined classes, the ones which you are defining yourself. You can define the class names all in caps or in title case, right? So that way it can be distinguished which are the classes created by yourself, right? By custom program, standard Python classes. Just to differentiate, you can use a naming convention of that sort, right? It's a very useful tip, I believe. Parentheses, I mean, as we just spoke, are optional. In case we don't have to inherit, we just don't need to have the parentheses. We can simply write the class name and then colon. That's it, right? Class methods. Class methods are functions that are defined within the scope of a class, right? So if I just I will look at it. So what is the difference between the class method and an ordinary function or a method? The difference is when we call a class, when we define a class method, I mean, when we are defining a ordinary method, we can just mention the arguments. But in case of the class method, the first argument is always the object on which it is operating. In general, whichever cases you will see, in most cases you will see self. So whenever we are defining a class, say for example, I'm defining a class, say the name of the class is card. Okay, within that, if I define a function, you will see the first argument of that function will be self, which indicates the class card itself. Okay, so that's the first argument, and then you can have the rest of the arguments. The first argument is reserved for the object on which the function is going to operate, right? Just a typical class definition. Here there is no concept of inheritance. I'm just creating a class card and I'm having an attribute card type, which I am specifying as credit. And then I'm having different functions like init is one function. Init is a very specific function. We are going to come very shortly. Then we have a function called debit, which is going to debit, I'll see, and then a credit, right? So what is the debit? The debit function, basically what it does is, there are two attributes other than card type, name and balance. So name means the cardholder name. So what it does is, when I have this init function called, an init function, will come to it in the next slide. Basically, I think you have all heard about constructors, right? Even in C++, we have the concept of constructors. What is a constructors? Whenever a class is instantiated, or whenever you're calling an object or creating an object, the constructor gets called to construct the object. And whatever things, whatever actions you want to put in at the beginning when the object is being created, you put it in the constructor block itself. So same way, init function is the constructor block or the function, the constructor method in the Python classes, right? So here what we are doing, we are assigning a default name, self name. So that means the card will have an attribute name where the value is being set in the constructor itself. When we are creating the object itself, we will see how it gets created. So when, and the balance also is being set at the beginning. Now when the object is getting created. Now when we are calling the debit function, we are passing a top-up value, right? And when we are calling the credit function also, it also is supplied with a top-up value. Basically, debit should be given the name top-down value because we are reducing the balance. And in case of credit, it is a top-up value, right? We are increasing the balance, right? So this is how the methods are being defined. And as you can see, the first argument is always self. Self means it indicates the class card, right? The card class, right? So when we are instantiating or when we are creating an object, this object card, obj underscore card, is the object we are creating of the class card. And here we are sending the arguments. Amit Kumar Das, that is my name. So the owner name is going to be set as Amit Kumar Das, and the balance, the initial balance or the initial credit limit is going to be set as 0. So 0 balance card. And then when I call the object dot credit, it is and load with the top-up value of 500, we'll see that a 500 gets added to the balance, right? We can just go to the Google Colab and we can try the same thing out, right? So we go to Google Colab, right? And we can create a class card, and we just give a colon, right? And then we give a def underscore underscore init underscore underscore, and then within braces we give what? We give self. Obviously the first parameter should be self, so self, and then we give the name. So I just give here a name, okay, and comma a balance, right? And then this is the function definition. What do I do? I simply assign. So self dot name is equal to name, which is being sent, and self dot balance is equal to, sorry, is equal to balance, right? And then I define the next function, that is the debit, right? So debit, and what do I give as the first parameter? Self, and the top up value, so top val, okay, and then I give a colon, and then what do I do? Just top up. So self dot balance, this is going to be negating it, right? So I have to, so this is the debit, so I have to debit it, I have to reduce it, so I give it as a top val, top underscore val. So basically what it means, self dot balance is equal to self dot balance minus top val. Same way I define the def uh, then credit, okay, def credit, and again the same way, self comma top val, okay, and then I give a colon, and then same thing, just here in this case self dot val is plus equals, because it's a credit, and then top underscore val, right? So I am done with the function definition now. Now when I want to call it, how do I call? I have to first create an instance of the class, and I have to create that as an object, right? How do I do that? Simple. I create an object obj card, okay, and how do I name it? So how do I call it? Card, and then if I see, I have a name to give, so I simply give as name as ABC, okay, and then I have to put in a balance. Say I put it as 1000, right? And then say for example I call the credit function now. So obj underscore card, okay, dot what do I say? Simply credit. So credit, and then what do I pass? I just pass a value. So say I top up with a value 500. Now once I do that, I simply want to see what is the balance. So print, okay, print the balance of the card. So obj underscore card dot, and then what do I say? Balance, right? So this should print the balance in the card. So let's see what is coming. So basically there is a small error here. I didn't mention balance here. I just gave a bal. So that's why it's a problem. Now I just rerun the code, and this time it should be fine. Yes. So see, I have initialized the card balance with 1000, and then I have used the credit function to top up with a value for 500. And when I print the card balance, it is showing me as 1500, right? So this is how we can create a class. Now, this is how we show. So basically constructors, we have just seen that init is the function where we can have all the activities which we want to set as a construction. I mean, when we construct the object, whatever activities we want to do. So we have seen how we can basically instantiate, or rather initialize the name and the balance when we create the object, right? So I just want to show you one small thing. I can create one more object. So the same thing, I just repeat it once more, okay? And I can create one more object, say obj card 1, and instead of ABC, I name it as XYZ, and instead of the balance 1000, I give it as a 500, and instead of a debit, I do, sorry, credit, I do a debit, okay, and debit it with a value of say 200. So what should I get when I print the balance? I should get, and let me print it as 1, okay, this is also 1. So when I print, I should get, initially it should be initialized with a value 500, then a debit of 200 happens, so I should get a 300. Let's see what happens. Yeah, we get a balance of 300 here. And if I just see the card name, so same way I can just see obj card1 dot name name, and if I do it, simply I will get a xyz, right? So here I am having two different objects, obj card and obj card1, and then we are simply just having them initialized in a different way, and then we are applying the function in a different way, right? So this is how we can use the methods in the classes, right? Now this is a constructor we have seen. Like in the same way, we can also define the destructor, and instead of init we have to use the function del, just the way we had defined the function underscore underscore init underscore underscore, same way underscore underscore del underscore underscore. This is the destructor. And why do we need, I mean, in general, the object, once the all the instances are being dereferenced, so basically the reference count gets to 0, so that time anyway the memory is being freed up, right? But in case you have some more explicit stuff to do, what all explicit stuff? Say for example, there are certain files which we have opened, which we want to close so that it doesn't have it open once the object gets closed, or there are certain network connections or certain system resources which has to be released when we are destroying the object, right? So that time you will have to put it, those activities, as a part of your destructors, right? Simple thing, we know, I mean, normal things that we follow in object oriented programming, same things here. Just the only thing which is different in Python is you use this del underscore underscore del underscore underscore function, right, for the destructors. Now, overloading of operators. This is another very important thing in Python. And how do we do that? Very, very simple way to do it. First of all, what is overloading? We know it. For the normal Python classes or normal Python types, already you have the class operator, you have the minus operator. All these things are kind of mathematical operators which are used on the standard types. But if you create a class and you want to define, say, the plus or addition operator for that class that you are defining, how can you do that? So for doing that, you have to overload the specific functions. Say for example, when we want to have a addition operator overloaded for a particular class that we create, what we have to do is we have to define the content for underscore underscore add underscore underscore. This is the function which we have to overload. What do we mean by overload? We simply have to define that function. Okay, simply have to, as a part of the class definition, we have to define the function, and whatever we want to do as a part of the function, we have to define it as a part of that function definition. Okay, so say for example, if we want to overload the add operator or the addition operator, right? So what do we have to do for that particular, say for example, in the card class itself, we want to overload the class operator or the addition operator. What do I have to do? Within the definition of the card class, I have to add the definition for this underscore underscore add. Okay, and then what do we have to do? Self and other. So there are two parameters. Self, anyway, we know the class that we are currently working on, and other is the other class. And what do we do here? Simple thing. We simply return a particular class object which has the name as a combination of the two names given as a part of the parameters, self and other, and have the balances as a sum total of the balances of the two objects, the balance of the two objects which have been provided as a input, right? So let's see with an example. Say for example, I create an object uh, for this card. Okay, so I just did that, right? So the first object I create is Amit Kumar Das, and the balance is 1000, and whatever we want to do it. Then I create another object, Raj Chatterjee. Okay, and then what do I do is I simply overload, right? But before that, what we have to do, I have to simply add the definition of this function, right? So let's try to do that. Okay, here we have to add one more function here. So def underscore underscore add underscore underscore. Here we give self comma other. Okay, and then we give a colon, and then what do we do? Simply return. Okay, return what? Return the first thing, self dot name. Okay, plus, okay, we just give a and, okay, and then plus other dot name. Fine, and then the same thing, self dot balance, okay, plus other dot balance, right? So this is being done, and here once we have all these things, we simply add one line of code here. So let me call this combination as obj combo. Okay, and that is simply obj underscore card plus, we are overloading this plus, remember, by this add, right? Obj underscore card 1. Okay, and simply we print print then obj combo, obj underscore combo, okay, dot name, and the same way we also do it as obj combo balance. What it should return? It should simply return the name as what? ABC and XYZ, right? This should be the name return. And what should be the balance return? Balance return should be 1500 plus 300, so 1800. Let's see whether that is the thing that we get here, right? So I just rerun because the class definition has changed. So I have to rerun them. I'm rerunning. So now I'm trying to run the overloaded function. There is a small error being thrown. And what is the error? It is throwing the error obj combo.name is throwing the. So basically, the obj combo is equal to obj combo card plus obj card 1. So I missed this card. I had to typecast it to the class. So but the return value which is coming in. Otherwise, how we did recognize that it's going to create an object of card, type card. So that's what I did. And now when I'm printing it, it is giving ABC and XYZ and 1800. So this is how I have overloaded this plus operator by defining this underscore underscore add function in the definition of the card class. Right now, there are more such more such operators which can be overloaded in Python. Say we just saw the plus can be overloaded with the underscore underscore add. Same way the minus can be overloaded with the underscore underscore sub. The asterisk, so the multiply operator, can be overloaded with underscore underscore mul underscore underscore. Like this, you have a whole list of the operators and the corresponding method which needs to be overloaded while doing the class definition, right? This is how we can do a overloading of mathematical operators. Actually, not only mathematical, mathematical operators, right? That can be of different types. Now, one thing we have to be cautious about, whenever we are trying to do overloading, we have to be sure that the overloading makes sense. Say, for example, when I was overloading the plus operator, in the case of a credit card or a card, it probably made sense. But if I am trying to do the same thing for a class which represents the HTTP, the HTTP class, then in that case the overloading operator of class doesn't make any sense, right? So adding to HTTP names or URLs doesn't make sense, right? So that case we should not be using this overloading concept. So we have to be pragmatic what exactly we are trying to achieve using that overloading operator. I mean rather operator overloading, right? Uh, Next concept, which is very important, is the class inheritance. How can we inherit classes? Again, very simple. As we are defining the classes using the class keyword, the one we had done now, the card class, we didn't use any parentheses, right? So we didn't want to inherit attributes or methods from any other class, right? But if we want to do that, what we have to do? We simply have to, oh yeah, I think here it is not done in the proper way. Here we have to use the card, the class card here, okay, and do the overloading. The inheritance. So when we have a card class, and when we try to inherit another class, say credit card, from the card class, we can do it simply by using the parenthesis when we are defining the credit card class, and within the parenthesis we name the class, the parent class or the parent classes if you want to inherit from multiple classes. So let's quickly look into that, how we can do that. So as we have done here, we define the card class. Okay, so let's just change the definition. Let's copy paste here and just do the redefinition of the card class. Okay, we don't need the operator overloading thing here. I'm just removing this, and let's just give a base name, and name it as a card. Okay, base name, and then one second, and then we have this same thing over, and we also define a credit card class. Okay, a credit card class. What we do, we simply uh, have the card as the parent class. So sorry, credit card. This is the class we are defining, and this is where I am defining which is going to be the parent class. Okay, and here I just give it as a subname. Okay, and subname I name it as a credit. Okay, and we do not have this debit and credit as the definitions here. We simply have it here. Okay, here we just have alternatively two other definitions. We have get name, okay, to get the name, and we don't need any function here, argument here. We just return the return the self dot name. Okay, so I'm just getting the name. Okay, and the same way I just want to get balance. That is another function I want to define, and here again I don't need the second argument, and I just have this return and self dot balance. Okay, so what I'm going to do is I'm going to, now here my definition is complete, right? So I'm just going to run this so that my classes are being created. Okay, now I just instantiate the credit card class. So obj underscore cr card. Okay, cr card, and here we just give card, sorry, credit card, oops, credit card. Okay, and within braces we give the name. Say I give a name Amit, and I give the starting balance as say 3,000. Okay, I'm using this, and remember, okay, I can remove this constructor. I don't need this constructor, as the base class constructor should be enough for doing this. Okay, I just remove the constructor. Since I'm inheriting from the parent class, I can use the parent class constructor to have the child class instance, right? Now what do? I simply call obj card card, obj underscore card, and then I do a, what do? I do a credit. Okay, I do a credit, say with a value, say 800. So 800 is the credit address. Next, what do? I call the, let me use the print function. Okay, print, and then I call the base class get name. Okay, I call a base class get name to get the name, and then I call the base class function balance, get balance. Okay, remember in the child class I haven't defined this get balance function. At the same time, I also want to see what is coming as my attribute value for base name, base underscore name, and what is coming as my attribute value for the subname. Okay, subname. Okay, this is how we do. So what we are doing, typically what we do, and that is the beauty of inheritance, we use uh, some of the functions or methods of the parent class, and we are defining some new methods, and we are also defining some new attributes, and we are using a mix of both, right? This is the beauty of inheritance. So when I run this, I think there is some stupid error which I've and the error is nothing but here the subname I have not given the underscore. So let me just do it again once more. So see the same thing, Amit 3000. So the credit card class is a child class. It doesn't have any constructor, but it is calling the parent class constructor to set the name and the balance. And once I do that, uh, uh, I'm calling the credit function, which is in the child class, to top up the value. I'm topping up with the value 800. Then when I get the name, I get the name Amit. When I get the balance, I get 3800. When I get the base name, I get the initialized name in the parent class. And when I call the subname, I see the subname, I get the initialized name in the child class. So this is how I can use the concept of inheritance to get some of the attributes or fully the attributes and methods of the parent class, and we define some more attributes and methods which are very specific to the child class. Okay, so I think this is, when I call this, I mean, we have already seen this, right? So this is a basic introduction to the concept of classes and the specific object-oriented programming concepts of inheritance and operator overloading, how it is being implemented in Python. Obviously, as you look into it into more complex programming, you can use these concepts and develop more complex programs. Okay, so hope this video helps you in getting the basics of object-oriented programming and the concept of class, the concept of operator overloading and inheritance in Python. So stay tuned and subscribe to my YouTube channel on the Python programming. Thank you very much.